Dimensional analysis can also be used to solve problems. For example, I have a density problem here. This density problem gives you 30 grams of vegetable oil. That's a mass, and it asks you to figure out the volume in liters. So the given here is 30 grams, and what you're trying to figure out is how many liters that would be. Well, the green sheet's not going to be as much help in this problem as the other problems. You're going to have to look into the problem and find conversion factors. And there are conversion factors actually present right here. It says there's a density of 0.91 grams per milliliter. What that means is that there is 0.91 grams in every 1 milliliter. So 0.91 grams is equivalent to 1 milliliter for vegetable oil in this problem. No other problems can you use that for. Well, looking at other useful conversions, I noticed that I have liters in one spot and I have milliliters here. So I might as well take the time to write down the conversion between milliliters and liters. And there's 1,000 milliliters for every 1 liter. So now I need to figure out how I'm going to go from grams to liters. And the path I'm going to take is I'm going to go from grams to milliliters using the first conversion, and then milliliters to liters using the second conversion. So just like before, I start by writing my given, 30 grams over 1. And I'm trying to get grams to cancel, so I'll put grams on the bottom and milliliters on the top. And I'm not done, so I need to add another line. Trying to get milliliters to cancel, so I'll put milliliters on the bottom, liters on the top. Once I'm comfortable that I've set up the dimensional analysis correctly, I go back and fill in the numbers. What do I know about milliliters and grams? Well, I go back up to this conversion that I got in the problem. There's 0.91 grams for every 1 milliliter. And, sorry, I'm making that a little darker. What do I know about milliliters and liters? There's 1,000 milliliters in a liter. So I'll put 1,000 milliliters to every 1 liter. Okay, now it's time for me to check and make sure that everything cancels out that's supposed to. So I'm going to take a look at the units that I have here already. I have grams and I have grams, and that cancels. I have milliliters on the top, milliliters on the bottom, that cancels. I'm left with liters, which is what I was supposed to get. So it's all about multiplying now. I just need to take 30 times 1 times 1, and that would give me 30 liters. Then I'm going to take 1 times 0.91 times 1,000, and that gives me 910. If I take 30 divided by 910, I get 0.033 liters. In this problem, we're going to convert miles per hour into meters per second. Miles per hour measures speed, and so does meters per second. But if you look at the green sheet conversion, there's no conversion for speed. But speed is a derived unit. It's distance divided by time. So if we can successfully convert distance from miles to meters, and then time from hours to seconds, and put that all together, we were able to convert the units of speed. So what I want to do first is I want to start by converting miles into meters. And then what I want to do is convert hours into seconds. So let's look at the path that we'll take. We want to go from miles to meters, so we will go miles to kilometers to meters. We also want to go hours to seconds, so we'll go hours to minutes to seconds. Now, what I'm going to do is I'm going to start by writing my given on the first fraction line, but instead of writing miles per hour with the sidewards fraction bar, I'm going to do it with the horizontal fraction bar. So I'm going to write 75 miles per hour. Now, in order to do this problem successfully, what you want to do is ignore the red part and just focus on the green part. So what I want to do is convert miles into kilometers. Miles is currently on the top, so I'm going to put it on the bottom. I'll go to kilometers. And since I'm not finished, I'll draw another fraction line. and I'll go from kilometers to meters. So at this point, I've successfully converted miles into meters, and if I look at the conversion, I've canceled out miles, I've canceled out kilometers, and I'm left with meters over hours. But the problem, I'm supposed to find meters per second. So I still have to convert hours to minutes to seconds. So now what you have to do is actually ignore everything in blue and just focus on what is in red. And you notice that hours is on the bottom. So what I'm going to do is I'm going to try and get rid of hours. And we know that we have to cancel top and bottom. So I'm going to put hours on the top and minutes on the bottom. Of course, I'm not done, so I need to add another fraction line. And now what I'm going to do is put minutes on the top and seconds on the bottom. At this point, it looks like all of my units are lined up. It's time for me to start filling in the numbers. Kilometers and miles, there's 1.61 kilometers in a mile. Meters and kilometers, there's 1,000 meters in a kilometer. Hours and minutes, 1 hour is 60 minutes. And minutes and seconds, 1 minute, 60 seconds. So now what I'm going to do is I'm going to make sure that all the units cancel out. So if I look across the whole thing, I see that miles cancel, kilometers cancel, hours cancel, minutes cancel, and I'm left with meters on the top, seconds on the bottom, which is what the goal was. So that's what I was trying to do. So at this point, it's time to take out the calculator and start typing things into the calculator. What I'm going to do is take 75 times 1.61 times 1,000 times 1 times 1, and I get 120,750 meters. And then I take the bottom and multiply all the numbers together. So there's really a 1 here, times 1 times 1 times 60 times 60, which gives me 3,600 seconds. If I take the numerator divided by the denominator, I get 33.5 meters per second. And that's it. In this next problem, I need to convert a volume to another volume. But the tricky thing about this problem is I need to convert centimeters cubed to millimeters cubed. And there is no cubed to cubed conversion on the green sheet. So what you actually have to do is think of it as centimeters to millimeters. But since it's not actually centimeters to millimeters, it's centimeters cubed to millimeters cubed, I'm going to have to do this conversion 3 times. So just like you always do, you'll start with your given. 15 centimeters cubed, and then what I would do is put that over 1 since there's nothing in the denominator. Okay, so as I said earlier, I need to go from centimeters to millimeters, and I need to do that 3 times. So what I'm going to do is put centimeters on the bottom, but I'm actually going to do that 3 times. Centimeters, centimeters. Okay, since I'm trying to convert to millimeters, I'll put millimeters on the top. Now what I want you to do for a second is think about, what does centimeters cubed really mean? Centimeters cubed here can really be written as centimeter times centimeter times centimeter. So if I think of it that way, this centimeter will cancel with this centimeter, this one with this one, and this one with this one, leaving me with millimeter times millimeter times millimeter, which is millimeter cubed. So now it's time for me to go back and put the numbers in. There are 10 millimeters in a centimeter, 10 millimeters in a centimeter, 10 millimeters in a centimeter. I always like to go back and make sure that things cancel out that are supposed to. And since I've written centimeters cubed as a centimeter times a centimeter times a centimeter, I notice that one of these cancels with one of these, and so on. Cancels, cancels. I'm left with millimeter times millimeter times millimeter, which is going to give me millimeters cubed. At this point, I'm ready to take out my calculator. I take 15 times 10 times 10 times 10. And I get 15000, 15,000 millimeters cubed, divided by 1 times 1 times 1 times 1, which is 1. 15,000 millimeters cubed divided by 1 is 15,000 millimeters cubed.